Very cool. Human physiology. Right here we have a person running, and we have a PQR wave from an EKG. And I think we did a lab on this, and we'll do another one here. But we're talking in this first section on a balanced diet. And that's what it is. When it comes to human nutrition, it's not some mystery, so it's no mystery. Okay, it's all about eating a variety of things. If you do that, you're good. A lot of times we think about taking vitamins, supplements. Please don't think you have to do this. If a physician tells you, yeah, you need an iron supplement or vitamin D or something like that, by all means do it. But there's really no evidence that vitamins really help you. What does help you? A variety. Mainly, most people have no trouble eating enough sugar, so you're good there. Most people have enough protein, but what most people lack in their diet really is fiber and water. So really, if you're looking at being healthy, I would just stress getting fiber and water. So eating salad, eating actual fruits to give you that fiber, and vegetables. If you can't do vegetables, at least eat apples, oranges, something like that. If you just eat a bunch of oranges, you get full. You won't feel like eating a bag of chips. And seriously, I love chips. Oh, I just had some Doritos Cool Ranch today. Man, I wasn't supposed to have those, but they went down good. Anyway, you hear, a lot in science. What we do is we find out new information, and then it kind of supersedes our earlier understanding. So that's what supersedes means. It kind of overlaps, or it kind of takes down the previous idea and replaces with another one. A lot of people think this is incorrect. It's like, oh, it's incorrect, or I guess that's not the best way to put it. It makes them mistrust science. So, oh, if you scientists thought, this before, then think this now, how can I ever trust you? But you really had to think deeper than that, and that our understanding is always changing, always growing, and we always got to do the best we can in a situation. If you need an operation, you go get it. You would go get that transplant, or have the doctor set your wrist again if you break it. You wouldn't say, wait a second, do you know exactly how to do this? Maybe we should wait 20 years until. No. Our best knowledge right now, and when we find out new information, we'll try something different. So this is a good example of scurvy could only happen to humans because they couldn't reproduce it in other animals. Well, later on they found out other animals can make vitamin C. Could make. So therefore they can't get scurvy. They make it. We're kind of unique in the animal world that we can't make vitamin C, so we get scurvy. And we'll come back to that a little bit, scurvy. But it's a good example of old scientific understanding getting replaced by new. Just think about, that's just a human thing. We're going to be pushing, we're going to be learning things. Think about phones, how they change, social media, how it changes over time. We're always getting the new, the fresh as humans. It's just what we do. So there's essential and non-essential nutrients. So essential nutrients cannot be made, synthesized by the body. So they cannot be made, that's what synthesized. So if they can't be made by the body, we need to eat them. That's what we're talking about vitamin C earlier. I'll try to make vitamin C. They must be included in your diet. Gotta have it in your diet. And building blocks of carbohydrates. So carbohydrates, the parts that make carbohydrates, proteins, lipids. However, you do not need to eat carbohydrates. Carbohydrates are not necessary. Make a note of that. The things that are necessary are protein and fat. You definitely need to have those. But your body can make carbohydrates out of these building blocks. minerals, and water. Of course, your body can't make its own water, although people get a little confused because in respiration you do make water, right? It's one of the byproducts, but that gets used up in the process and you lose it. And play a vital role in these metabolic process of your tissues and organs. Non-essential, they are made by the body, but you can also absorb them from food. So that kind of absorb. Yeah. So you can save your body the trouble by eating them. Synthesized. Oh, check that out. That's some good handwriting. Either way, body can make them, or you can synthesize. So biotin, vitamin K. This is one we talk about in your large intestine. You have bacteria that can make that. Vitamin K, cholesterol. We'll talk a lot about that later. Big buzzword. I know you all have heard of cholesterol. Fiber you need, like I mentioned, amino acids and fatty acids. So remember, amino acids to make proteins, fatty acids to make triglycerides. Yeah, fatty acids and glycerol, but they have significant effect on your health. Okay, getting these nutrients. So you need to get these fatty acids. These are your essential ones: alpha linoleic acid. Also, usually we hear omega-3, omega-6. So here you got nuts. You've heard of flaxseed, walnuts. Actually, I think that's actually fish. So here is fish. Sorry, hopefully you weren't so fast writing that in. So omega-3 fish, and then omega-6, you got those in nuts. So things like sardines are fantastic. Any kind of fish will have omega-3, but sardines that we had, you had that last year when we did topic 5 in food chains. We had a little lab where we ate tuna and anchovies. If we didn't, please remind me next time we're in class, and we will do that because it's a real kick. Try to get high school students to eat sardines. And you need these fatty acids for healthy brain and eye development. So as you'll see, fatty acids, you get them from fat. So you need fat. So you need fat in your diet. You need a certain amount of butter, red meat, milk, cheese. It really does help. You can get away with not having it, but for most people it's easier just to have a little bit of cheese or milk or some kind of animal fat. When it comes to amino acids, the essential ones are on the list here. This is histidine. Gotta get my handwriting on point here. Write it big up here. Histidine. Getting used to a new pad here. And then valine also. These are kind of fun to pronounce. Isoleucine, leucine, lysine, methionine, phenylalanine, tryptophan, valine. Conditionally, so like this is in a baby's diet. That's what we got in a baby's diet. But later on, your body usually can do that. So what we have here, we have a child who hasn't been getting enough food, but you'll notice a lot of people when they're starving, their belly will push out like that. And that's a type of swelling called edema. And what happens is proteins enter the bloodstream. When somebody starves like this, their body's breaking down these proteins and trying to use them. And when that causes tissues to swell. So edema, and that tissues swell. So it looks like, you know, their belly is big, like they're eating, but they're really not. I remember when I was a kid, there's a lot of talk about drought and major starvation in parts of Africa, Ethiopia at the time, and you'd see images. They play a lot of ads to get people to donate, and they play images of little kids, and their bellies would be pushing out. And as a kid, I'm like, wow, they look like they have a big belly, but that's a real indication of starvation, and it's from you know, lack of calories, quality calories. So here is, check out the periodic table. Lots of fun. Your diet basically in these minerals, and you can see, oh, these are all the micro minerals and trace minerals. You know, carbon, nitrogen, oxygen, like no sulfur, phosphorus, chloride, sodium, but also cobalt, nickel. You need a trace of those, a little bit of zinc, and that's what we got going down here. These are your essential dietary minerals: calcium, iron, sodium, and zinc. All different kinds of chemical processes are going to rely on those. So this is a cool little image. Your body is on average 62% water and 16% protein. So mostly water weight. 16% of your body is fat. And if you're looking at, you know, males versus females, males will be slightly higher in water percent. Females slightly higher in fat, slightly lower in slightly lower in protein, but that's just an average. That definitely varies, but that's in generally that's the average. So, and then 65% of your body is the element oxygen, and by weight, because remember, mostly your water, H2O. You think, oh, you have two H's and only one O. Why is it so much O? Well, the molecular weight is much higher for oxygen. It's 16. Hydrogen is 1. So it's heavier. But you see all these other trace elements. Well, carbon is not trace, but 18% of your body is element carbon. And then you have some of the other ones: magnesium, sodium, chlorine, you know, that make up salt that you need. Interestingly, you know, this carbohydrate, that's why your body stores energy as fat, because you can hold on to a lot of it. Your body is not much, by weight, not much carbohydrate. Mostly the weight of this would be in your liver, when you store glycogen, and some in muscles. If you're an athlete, do a lot of training, your body starts storing more in the muscles. So vitamins, organic compounds, need in small amounts, and coenzyme, antioxidants, hormones. Vitamin D is similar to a hormone, really. And vital amine, because, you know, they had some amino groups when they first discovered them. So water soluble, they're not stored in the body. They have to be constantly eaten. Things like vitamin C. People eat huge doses of vitamin C. Most of it gets peed right out because you can't store it. Fat soluble can be stored in the body, and specifically in your fat tissue, your adipose tissue. Malnutrition, taught you malnutrition, usually from low protein, low calories in general, missing some essential nutrients, usually it's protein, but remember how for most Western diets it's fiber if you're not getting the right stuff. Excess, a lot of people do end up eating excess fat, but the main thing is the big killer from all the research so far: refined carbohydrates. It's interesting because kind of a setup from the beginning was the sugar industry was really booming in the 50s, and they didn't want people to come after them for being responsible for bad diets. So they start to push the idea that fat was the problem. And unfortunately, that caught on, and people kind of overlooked carbohydrates for about 30 or 40 years until, like, wait a second. People who eat lots of carbohydrates don't do so well. Starvation, lacking calories, usually in the form of protein, fats, and obesity, excess body fat, and you're seeing a lot more around the world now. People are moving into the middle class, access to more food, but it's interesting. You do see a connection with socioeconomic status and poverty. People that are wealthier tend to afford better diets, ones with lower amounts of sugars. So appetite, you've all wondered. I've always been to that point, sometimes eating more than you really need. But when your stomach is full, you have this thing called the vagus nerve is stimulated. And that tells you to stop. But we know people are different, right? Some people maybe have an overactive vagus nerve or underactive vagus nerve, and that can cause real problems. Over here is a hormone called leptin. It also acts on your brain. That's stored in your adipose tissue, which is a fancy word for fat. So that's fat tissue here. Adipose, it releases the leptin, also comes and tells your brain to stop. So you got your vagus nerve. Let me write that even bigger. It's a fun experiment I want to do with the vagus nerve, but it involves sticking your face in cold water. Maybe we'll get that going. So this is like 2 stop signals. Stop, stop. Oh, I forgot. Protein is released by your small intestine. The very hard to remember name, PYY3-36. Gotta come up with something better than that. And then leptin. So the vagus, YY-36, PYY3-36, and you have leptin, all influencing the brain to get you to stop.